Okay, here we go with our next presentation. Before we get started with the presentation, let's talk about what you want to get out of this in the long term, or what I'd like you to get out of it. And that is, by knowing some things, you can find out a bunch of other things. True in lots of things in life, and also true here with physics, that's for sure. So in kinematics, we're talking about a description of motion. I'm coming to you live from my office. Watch me turn the lights back on. Hey, pretty impressive. All right, so kinematics is a description of motion, and that's what we've been doing so far. And a good question to ask is, what can we do if the speed is not constant or doesn't stay the same? Something to think about as we get started. All right, so far we've been using the equation d is equal to v times t. Distance is equal to speed multiplied by time. And for this equation to work, that v, that speed, has got to be either constant or an average speed. But now we want to get a little bit more powerful in our calculations and talk about when speeds change, what's going to happen. All right, so now we're going to introduce two new symbols, because if a speed is changing, we would want to be talking about the speed at the beginning and the speed at the end. So the two new symbols are going to be VI for V initial, that'll be the starting speed, and VF, that'll be the final speed or the new speed. Okay, so acceleration, our topic for this presentation, is how fast the speed is changing. So it's not just the change in speed, but it's also how fast that's happening. So time is going to come into it as well. So now we're also going to introduce another new symbol, and that is A for acceleration. Okay, so our second kinematic equation is going to look like this one. Turns out the final speed is equal to the initial plus the acceleration multiplied by the time. Okay, and for the calculations that we're going to do in class, the unit for the acceleration is going to be meters per second squared. Remember, as we discussed, those units are pretty important for figuring out what you're talking about. Okay, so here's an example problem. Let's go through this one together. As always, the first thing that we're going to do is identify the information. So here, the acceleration is 12 meters per second squared. That unit, meters per second squared, lets you know it's an acceleration. If the object starts at rest, and what's its speed after 5 seconds? Well, the time, the t, is going to be 5 seconds. And since it starts at rest, we can say its initial speed is 0 meters per second. Okay, so then we're looking for the final speed. I also include that variable. What's the one piece of information we're looking for? All right, well, here is our equation, and now it's a matter of plugging the numbers in, the step where we show our work. So here I'm plugging in the values for everything that was missing, then doing the math, and coming up with the correct solution. So the final speed, 60 meters per second. Okay, does that make sense? Hopefully it does. All right, so now you might want to ask, how far did the object move during that time period? Well, we know it's not a constant speed, so we can't use either the initial speed or the final speed. But remember, in the equation d is equal to vt, v could be the average speed. So the average speed is going to be our initial speed plus our final speed divided by 2. The average of any two numbers is going to be adding the two numbers up and dividing by 2, and it's true for average speed as well. So for our problem that we just discussed, the average speed is the initial speed 0 plus the final speed 60 divided by 2. Of course, then the average speed would be 30 meters per second, and now we can get an idea of the distance. Using the equation, d is equal to vt, where v, the average speed, is 30 meters per second, and the time is 5 seconds. Pretty good? Hopefully understandable. If not, ask questions in class. That's what class time is for too. All right, so here's a problem for you to try. Why don't you do that? Why don't you pause and see how you do? Then I'll come back with the solution. All right, well, welcome back. Here we go. Object is moving at a certain speed. After 10 seconds, it has a new speed. What was its acceleration? Okay, great question. Well, the initial speed is 10. After 10 seconds worth of time, it has a final speed of 50 meters per second, and I'll include the time here as well, and also what I'm looking for, which is the acceleration. Okay, so if I start with my equation, v final, I can plug in my information. And here's where the algebra comes into play, and I know some people struggle with the algebra. In my mind, with the algebra, what we're always trying to do is isolate one variable. Everything else has to go to the other side. Here we're trying to get acceleration by itself, so we have to get rid of the 10 over here and the 10 that is attached to the acceleration. When I finally figured out algebra, I figured out that when I'm moving things over, if there's more than one thing to move over, I want to move over the thing farthest away first. So I'm going to try to get rid of this 10, and since it's added on here, I'm going to undo that addition with subtraction. So my first move here is to subtract off the 10 from both sides. When I subtract off the 10 from both sides, I'm left with this. And now I want to get rid of this second 10, the one that was a little closer to the A that I want to isolate by itself. And here, since this is multiplication, I'm going to undo the multiplication with division. So dividing, I'm going to end up getting, dividing both sides by 10, I'm going to get the acceleration by itself, and I'm going to get an answer of 4. Okay, hopefully that's understandable. If not, again, you can ask questions in class. That's what class time is for. Have I mentioned that already? Okay, well here's a question for you. What is the unit going to be? Because all of our answers to get full credit are going to have the correct unit as well. Do you remember the unit for acceleration? Well, it's meters per second squared. Pretty good. All right, well, that's our presentation for today. Again, bring your questions to class, and I will look forward to seeing you there the next time we get together. Thanks for coming by.